All right, 11.5, areas of circles and sectors. Circles, easy business. Sectors are just the parts of the circles given some ratio of the angles. This is the formula for the area of a circle. Should be a lot of you should have had a lot of practice on this in middle school. Pi r squared. So if you're given d, you would just divide by 2 because that's the radius, and then plug it into the formula to find the area. So if I had these indicated problems, by the way, you should be drawing these in your notes, and we have a radius of 2.5 of this given figure, then we just simply plug it in for the area. Area equals pi times r squared. R is 2.5, so we square it and multiply it by pi. That's a simple plug and chug. I'm going to leave it for you to type that in. This is centimeters squared. If you have the diameter, whoops, we have the area in this case, and we're supposed to find the diameter. So let me go ahead and erase this. Have the area. Now the area is equal to pi r squared. If I were going to derive a formula to find the diameter, I would simply divide by pi, and then I would set it equal to r squared, and then r is equal to only the positive square root, because radius is a positive distance, of the area divided by pi. And then if I want to find the diameter, just simply multiply that by 2. Yes, this formula looks crazy, but it's pretty simple to follow if you go through with it. If you want to just solve this particular problem, you could just simply type in your values with the area and then plug it in here, divide by pi. You'll have to end up doing this and then square rooting it. But I prefer to create formulas because it allows me to do multiple problems like this quickly and efficiently. But I'll allow you to look back at your notes or the textbook to find this exact answer. Please get the practice doing that. Go ahead and draw what you see. I'm just going to establish a few things about this. Now this M arc AB is the measure of the angle that corresponds to arc AB, and that's this angle right here. Notice if I take that angle and divide by 360, I'm getting the part of the circle times the area of the circle. That gives me the area of the sector. A sector is a part of the graph. This is very similar to the equation for the arc length. This is the area of a sector. If I find the arc length of a sector, it's equal to the part of the circle times the circumference. Notice that's the same idea here. So all you really have to remember is the area formula and the circumference formula and plugging them in. Go ahead and draw this problem in your notes. The directions for this problem is to find the area of both sectors. So I'm going to find the area of the small sector and then subtract it from the circle to find the total. Notice we have a radius equal to 8. The formula is 70 divided by 360 because that gives me the part of the circle that this sector is right here. Let me erase that because it's in the way. The area of that sector times the area of the circle. Pi r, r is 8 squared. Now it just comes down to typing this correctly. Do this with me, please. I get the area of that sector, the small one, equal to 39.1, roughly. And this is just units squared. Now if I want to find, I'm going to call this sector 1, and the sector 2 is the big one. Notice it's just the area of a circle minus the area of sector 1 to get the area of sector 2. So I just take pi 8 squared and I subtract away the 39.1 that I have stored in my calculator to get the area of 2. Area of 2, let me go ahead and type this in, pi r squared, 8 squared, and I subtract away the answer I had from before. I get it to be roughly 160, actually rounds up to 162 units squared. All right, go ahead and pause the video, try problem 1, 2, and 3. And then unpause it and see if you get the same thing I do. We're looking for the area of circle D, we're looking for the area of the red sector, and the area of the blue sector. Area of the circle, pi r squared, plug and chug. Area of the sector, area of the circle, times the part of the circle that the red sector is. Area of the blue sector, I could do the same thing I did here, 360 minus 120 divided by 360. I think it's easier since I already have these two values to subtract the area of the sector from the area of the circle. Now this is where things get a little tricky in this section. In this particular case, we're given the area of the sector, not the area of the circle, and then the part of the circle that this sector happens to be. We're asked to find the area of the circle. Now the area of the sector, 35, is equal to the part of the circle, 40, divided by the total degrees 360 times pi r squared. Now we're asked to find the area. Let's pause for a second and notice something about our equation. This right here is actually the area. So I don't need to write pi r squared because then I'd just be doing more work than necessary. Notice it's equal to the area. So to solve for the area, I just multiply both sides by the reciprocal of the fraction. So the area is equal to 35 times 360. Actually, the zeros cancel to make this simpler, and I could make this 1 over 9, but whatever. Go ahead and simplify this. This is 35 times 9 because 4 fits into 36 9 times. And then it's just a simple plug and chug from there, being that 35 times 9 is 315. So the area of the circle is equal to 315 meters squared. Notice I bypassed even finding the radius because it's just a part of the circle. Alright, in this particular case, we're asked to find the area of the shaded region, which is the paint that this person's going to be painting. Notice it's just the area of the rectangle minus the area. Now in this case, it's a semicircle, which is half of the circle. So I'm going to write S for semicircle. And then this is a square because it's 12 by 12, so the area of the square. Man, I can just make up some other letter. I'll just write SQ to identify which it is. Once I get this written, I can go ahead and start establishing each of the values that I do have. The area of the rectangle is 12 plus 8, which is 18, times the base, and that is 28 in this case, 28, minus the area of the semicircle, and that's half of the actual circle, which is pi times the r. R is half of this distance, so that's 6. Then subtract away the area of the square, 12 squared. Now a recommendation at this point is that you don't worry so much about the arithmetic. Our graphing calculators do this arithmetic in one swift move. So type that in one swift move, pause the video and see if you get the same thing as me. I typed this in one swift move and I got the area to be approximately 350.58. 350.58 feet squared, which when given the answer choices is obviously C, which you'd bubble in. Alright, guided practice number 4, 5, and 6. I'd like for you to pause the video, try these problems, and see if you get the same thing as me. Alright, for number 4, I got the value of 907.92, just using the area of the sector, part of the sector, and the area of the circle, and I just flipped this, multiplied by both sides to get that. Over here I've got the area of the circle, and this is actually a semicircle, so it's half of the actual circle, and the radius being 7 divided by 2, which is 3.5. Then the area of triangle, that's a T. And I just add those two together, type it in, I get this. The next case we're asked if the area and radius of a sector, if you know those two things, can you find the intersected arc length? Notice if we know the area and we know the radius, then we can find the angle that goes with that. Theta is right here, that angle inside. If you know that, then you can divide by 360 and multiply by the radius to get the arc length, S. I decided to go and pick out a few word problems or a few problems here because this section is a lot about problem solving. Now notice in problem number 18, if you'll go and draw this in your notes, we've got the area of a trapezoid minus the area of a semicircle. So the area of the trapezoid minus the area of the semicircle to find the area of the shaded region. Let me pause for a second and say it's really important that you set this up because it helps you to see where you create your new formulas. Now it just comes down to plugging and chugging. The area of a trapezoid is 1/2 times the height times the base 1 plus the base 2. And yeah, like I said there. Now the area of the semicircle is a little bit trickier. We need to find this distance here. Notice these two segments are marked equal and this is parallel, which means this is the mid segment, which means this is split into 2 equal pieces, which means the radius is 4. 1/2 pi 4 squared. Go ahead and type that in your calculator in one swift move. Don't worry about doing simplification here because the calculator can do the work. I want you to be more consumed with setting up your equations from the geometry. See if you get the same thing as me. I get, when I type this in one move, area to be 118.87, and this is in inches squared. A lot of these problems are going to require a lot of thought or applications of things from the past, so just keep that in mind when working these out. Notice this radius is equal to this radius, which is equal to that radius, which means this is an isosceles right triangle. This, I'm quite confident a lot of you are going to miss up on. So I'm going to do this again to talk about it so that you can catch what I just said. Now, this is the radius, this is the radius, and this is the radius, which means that this is an isosceles right triangle. I need to find the area of the the area of the circle so that I can subtract away the area of the triangle. And I've got to find all the parts necessary to plug into this formula, pi r squared minus the area of the triangle, which is base times height divided by 2. I should probably write that a little differently as little b times the height divided by 2. Got to do some work. Now, I'm going to go ahead and plug in what I do know. I know that the base is the total radius. Actually, I don't know that yet. So let's go ahead and find that base. Now, from special right triangles, we have x, x, and x root 2. If I have the x root 2, which I do in this case, and I need to find x, then I just set x times root 2 equal to 5 so that I can find my x. Now in this particular case, I'm not going to worry about simplifying that. I'm just going to leave it as is. Now the radius, by the way, this is equal to the radius because that's this particular case. Notice the base of the entire triangle is 5 over root 2 times 2. That's the base. Multiplied by the height, well, the height is the radius, 5 over root 2. And all of this is being divided by 2, as you can see from here. Don't worry about the arithmetic just yet. At least set it up this way. Now pi r squared, the radius, is the 5 over the root 2 squared. Now, at this point, I'm hoping that you can see where I got this set up. This is the geometry, which is a good, valid step that you can write to convince me you know something. Then, writing in your formulas that you need for this given geometry problem. Then the next part is working with special right triangles and getting this. Now it comes down to the arithmetic. Now in this case, I'm actually going to simplify as I go because this is going to be pretty messy if I type it in the calculator just as it is. So let me simplify. 5 squared is 25. Square root of 2 squared is 2. This is still being multiplied by pi. I'm just moving it over here to keep it cleaner. Now, the second one, we have 5 over root 2 times itself. That's the same thing, 25 over 2. This is being multiplied by 2, then divided by 2. Now it comes down to some other arithmetic. Notice 2 divided by 2 cancels. That leaves us with, let me scroll down, leaves us with 25 over 2 times pi minus 25 over 2. Now it just comes down to typing this in the calculator. And I'm just going to type it in one swift move. 25 divided by 2 times pi minus 25 divided by 2. That is the area of 26.77. And the units we have here are inches squared. Alright, that's it for the video. I think we're going to leave some of these problems for practice in class. Come prepared.